Hi there, Alucard J here with another standalone video. This one I'm going to be looking at collecting papers using a SphereCast. First of all, let's just have a look at the Raycast again and what that was doing and how that was working. Just going to edit that script again. If you remember, I added a Debug.DrawLine to physically represent our array. I just want to show you something, so I'm not going to destroy any papers. So if we look at how the Raycast currently works, or how a Raycast does work. We have our player, come up to a paper, we see the paper is within the center of the screen, we hit the E. There is our ray. It's cast from the center of our screen to exactly where we're looking at. Now you can see a problem with this immediately. If the paper is in your view, but the paper collider is not lined up to the center of the screen, I press E, there is no debug. That means the ray didn't hit anything. Bring that back over, and there we go. The collider is now in view of the center of the screen for that ray to intersect. Okay, so there's a problem. Now I was thinking about this, and people are still having problems with collecting papers. Well, there's another way we can do this. I'm going to do a SphereCast. So let's just look at it one more time and bring it up. Okay. So this is a Raycast. We're casting a ray from the center of our screen in the direction of our view. Now SphereCast is casting a sphere instead of a ray. So if you can imagine a ball, a sphere, going to be travelling down that line, just exactly like the line the Raycast did. So we have a sphere. So in the end, you kind of like have a capital shape. Or if you can't imagine that, just imagine this line you are now making thicker. It now has a width. It's like a circle. Okay, you can cast a big circle all the way down here. Okay, let's have a look at that. First of all, this is a standalone, so I'm going to build this from scratch. We can remove the character controller. Okay, so we have our new blank empty project. First of all, we'll create a couple of materials. Create a material, we'll name it floor, and we'll give it a wood body color. Next, we'll create another material. We'll call it paper, and give it just an offset white color. Contrast. Now we need our character controller. Assets, import package, character controller. I'll bring everything in. And I showed this on the first video, but I'll show one more time. You'll see there is a warning that comes up with the third person controller. Here we are. What does it say? Bitwise operation a single slash. Pull back. Did you mean this? Alright. Now, if in the console, if you see an error message, double click on it for a warning error. See, Unity will open the script and will also highlight the line which you found the error. If what's happening here? We're looking for an if something happens, we're looking for an input with a left shift, and over here, looking for an input with a right shift. And as Unity suggested, this could most likely be or. We're looking if there is a left shift or if there is a right shift. Save that out. Don't need that anymore. Let's check Unity compiling that. And there we go. That's how to fix that little warning with the third person. Okay, back onto our new scene and collecting papers with a SphereCast. First we create an object for our floor. It's going to be a cube. We'll name it floor. We'll set its position. And we'll give it a floor type scale. Apply the floor material. And we have a floor. Now we'll create a directional light, just so we can see the objects in our scene. I like to raise that way out of the way. There it is. Let's build some papers to collect. So again, create a cube. Name it paper, set its position, and we'll give it a paper scale. Apply our paper material, and there we've created our paper. Now we'll duplicate that to make a total of 8 papers. We'll spread them around the scene. And there we have our 8 papers. Let's bring in our character. First person character controller. It's going to be a player. Let's name it player. We'll set its position to the world. Bring it into the world. Now, of course, first person controller has its own camera. That is what you, the first person, can see, or you, the player, can see from a first person perspective. So we'll delete the default scene camera that comes from the scene. So there we have it. There's our scene all set up. We'll save that. And this one is collecting papers with a SphereCast. Now let's just check. Let's see what we've done. We've built a scene. We have a first person controller, which behaves as expected. So far it can walk and look and it can jump. And we'll move on to those colliders. There's our scene. Let's start adding our functionality. We'll create a JavaScript. We're going to be collecting paper with SphereCast. Script ready. What many people may not be aware of or just don't know how to use is the Unity scripting reference. Every functional command that is built into Unity which you can use and find will be here. So let's look. SphereCast. It gives us a couple of results. Let's look at one of these results, the first one. And there we have it. There is our SphereCast function. Might be hard to read, but it does actually explain exactly what it's doing and exactly what it's looking for. We have some more description down here. They'll usually give us an example. Sometimes you'll find some amazing bits of code and examples. Unity's already giving away code. It's all here in the Unity scripting reference. Okay, so let's have a look at this function. It's similar to a Raycast. It's just like a brother to the Raycast. So we have a SphereCast. We have an origin, we have a position where that SphereCast starts. This time, we have to give the SphereCast a radius. How round is our sphere going to be in our SphereCast? So like I said, how thick are we going to make that line? How round? Okay. And then, just like the other, we have a direction. So we have a direction in which we send that SphereCast. Okay, we're looking for if it hits anything. So we store a variable that will contain any hit information. We set a distance, so we tell it how long to cast that sphere for. And then finally, something I haven't covered, which will be coming in the future, is layer mask. Okay, so you can set your colliders to certain layers, and then you can tell your SphereCast or your Raycast to only detect colliders on a certain layer. That'll come later. So let's start building this script. Now, I'm going to cheat and copy a little bit, just to save typing errors and a little more time for explanation. See, I have the old script here. So on our new script, we'll create a variable. We'll call it papers. This variable is of type integer, and it starts at 0. This is just a counter. Okay, how many papers have we picked up? Now, our second variable is papersToWin. This is a variable of type integer. And this is the total number of papers in the scene. So when our count reaches this amount, we picked up all the papers. We have something to check. Our next variable is distanceToPaper. Now this I just described a moment ago in the SphereCast. Distance right here. How far we're going to be casting this sphere for. Alright? Now this is different to a raycast in that we have one more variable called radius. So let's make a variable for us there. Variable sphere radius. And this is of type float, so we can give it uneven numbers. And let's just do some testing. By default, let's just make it the width of the player. So 1.0. So there is our sphere radius. Okay, save that out. There's our variables. So we're going to start looking at our functionality as this script is running. In the update, first we're looking for any player input. So if input, we're looking for a get mouse button down, and that button will call 0. So in the game, they use the left mouse button, or for our testing in the editor, so that we don't break the mouse when clicking around, we're looking for Input.GetKeyDown. Okay, and I'm going to use the KeyCode.E num, KeyCode.E. So this is just for testing in the editor. The player might like the E key. If the input mouse, left mouse button, or if the E key is pressed, we're going to do something. First of all, we're going to set up just a couple more variables for our array. First we need hit, and that will be our Raycast Hit. And I spell it right. This is going to be our variable that just stores any information from the raycast if it hits anything. Now we're going to define our origin just as last time. So bar ray origin. Okay, this is a ray origin, so it is a ray. Where is it coming from? Well, it's coming from the Camera.main.ScreenPointToRay. No. Camera.ray equals a Camera.main.ScreenPointToRay, and that is a vector 3. That's why I left this one open. I called it ray pause here. Ray origin, casting array, Camera.main.ScreenPointToRay, vector 3, which is built from half the screen width, half the screen height, and 0 away. So this is giving us this point right in the center of the screen. So we can use that. Got halfway there. Everyone can see what's happening there. Okay, now let's cast our ray. Let's cast our sphere. Because we are sphere casting. Check the API for this. If Physics.SphereCast. Now, what is our SphereCast looking for? First, our origin. We've just assigned our ray origin. It's going to be the center of our screen and forward. Ray origin. Yep, I just realized I was using a different kind of setup, so it's not going to be that unique. Okay. Because in our ray declaration, we've already given it a position and a direction. By using the Camera.main.ScreenPointToRay, it is saying from this position on the screen, from this vector 3, so half the screen width, half the screen height, 0 away, from this position in the screen, casting from the Camera.main.ScreenPointToRay. It's kind of basically saying from the center of the screen in the camera forward. So whatever is directly forward of the camera. So this little variable here has already given us a origin and it's also given us a direction. So instead of using origin direction, we have another definition here. we have the ray, we have a radius, and you see there is no origin or direction. Just jump to the outer end. So our function will be looking for this too. So if physics, rayOrigin, let's give it our radius, our sphereRadius, our out hit info. That's our hit information, right? So we've got hit right here. Where are we up to? We'll cast our ray with a radius, looking for some hit information, and we give it a distance. Okay? Distance to paper. Now, we're not using layer mask, so there we have it. Command, didn't really know. With the help of the Unity scripting reference, we've been able to use that. Okay, we're now casting a sphere from using this ray command. We have an origin and we have a direction. So we're casting our ray and casting our sphere, and our sphere has a radius. It is looking for a hit, and it's only being cast for a distance of distance to paper. Now, this is the functionality. Everything we add in afterwards, play sounds, play up a particle effect, make a scary noise, destroy the paper, everything happens after this. It's all inconsequential, okay? So for now, we've got all the working logic happening. Let's just do a debug. Debug.Log. Okay, what's it going to tell us? Okay, so we want to know our SphereCast hit something. So what are our SphereCast hit? I have a latent pinky finger. It tends to hang onto that shift long after I've moved on. So we are looking for our hit information. I can't copy it. Hit and the collider of that hit, and the game object of that collider, and the name of the game object with the collider that we hit. So let's try that out. Save it, bring back to Unity, check for compilation errors. We have no compilation errors. So let's hit play, see what's happening. Let's just keep checking the console. Hit the E, and nothing's happening. Now, can anybody guess why nothing's happening? We look at our player. Yeah, sure, we brought our player in. We haven't attached the script. Okay, so here's our collect paper being attached to our player. Save that. Now let's test. We have our player walking around, come within a view, hit the E. There you are, SphereCast Hit paper. So it's pretty much doing exactly the same thing as a raycast. Well, what was the point of all that? Well, let's test what I originally brought up at the start. If the paper is not in the center of the screen, we can quite fairly say that paper is not in the center of the screen. This is where our raycast would fail. Let's just hit the E key. There we go. I'm going to pause it. I'm going to clear my console. I'm going to unpause the game. And that was just me hitting the mouse. Alright, so we see one. Okay, there's our paper just off to the side. Let's hit the E. There we go. So we're not even directly looking at the paper. And look, we're even still hitting it at this kind of width. Yeah, that's actually still hitting floor. So we're finally getting to that point. Now this is where you muck around with your game. You start testing things. So, okay, I'm play testing. Now I hit it. Look, that's the same paper. The floor. Gee, that thing's going for miles, isn't it? How far away can we get? There's another paper. There's a floor in there. Floor. So you can see this one is actually returning a lot more information than the raycast. Now why is this? This is as I was trying to describe with that red line I had debugged before. Now previously we were casting a single line to the center. Now we're casting a circle, okay, a sphere in fact, okay. But just imagine a circle. That line now has thickness, okay, and off it goes. So anything within that thickness is now being picked up. That's great. That's just given it more sensitivity. Let's see that just like I did last time. We want to see a kind of representation of the sphere. Now there's some amazing ways in Unity of doing this. It could be quite easy if I knew on gizmos, on Gizmo Draw. That is something I'll be teaching myself and then showing to other people, because it's actually very useful for seeing things in the edit view, in the scene view, to finding game objects. Anyway, that is a sidetrack, but just to let you know, there is a function called Gizmo, on Gizmo Draw, and there's these things called gizmos. But what we're going to do is the same thing as last time. Okay, we're going to draw a line. Debug. Okay, let's test something right here. Is there a draw sphere? Gizmos. As I was saying, there are these lovely things in Unity called gizmos. Okay, but I'm not going to muck around with that because they do have their own function. I'm just going to show you the draw line. Okay, so same thing. There we draw a line. We give it a start position. We give it an end position. We give it a color. We give it how long it stays on the screen for. Let's just wind it out. Debug. Draw line. Casting from the camera. So it's the Camera.main.transform.position. So that's where our line is starting, and we want an end. Now I did use hit point. Okay, like I said, this hit, this Raycast hit, it holds a lot of information in that Raycast hit. As you saw, we can go through the handles of the components of the game object and look through those different things. We have some other information. So the hit point. What point in world space did our ray hit? So that's going to be end. Give it a color. I gave it Color.red last time. Red. And a duration. I said if we only hit the button once, we won't want to see the line, so I'm just going to give it a generous 1.5 seconds. So we can see what's happening. I'm not going to touch depth of text. So let's save that out. So I was doing the same thing as last time, it's just showing us our line. Right. As you can see, if I'm not looking at, alright, let's bring the scene view to something. That debug to disappear. As I said, I'm not looking at that paper at all. It's definitely not in the center of the screen, is it? But I hit the E. There we go. It's kind of represent. Oops, I didn't pause that quick enough. Let's try that again. Okay, so as you can see, in this view, I'm clearly not looking down the center of the screen. But our debug is showing us, yeah, but look, from our camera, we were casting a sphere that's as wide as the player. So you can see, this is how wide our player is, 1. Okay, so if we cast a sphere that is of width 1, in the direction that the camera is facing, obviously there was a hit somewhere along that sphere cast, and it's saying, yeah, the side of the sphere hit that paper. Okay, so even just with the line, I know that's kind of hard, but is that visible? Can people kind of see what's happening there? Okay, let's try it again. So if we look dead center of the screen, obviously Ray is really noticeable. We'll bring it up to the side, so that. Okay, and even if we bring it out a bit more, look, that sphere is obviously a little bit wider than that one. Okay, that's still detecting. There we go, now it's finally hitting the floor. Okay, now I tend to ramble on that, but I think maybe this has shown off enough what I was trying to show people here. Okay, we have a sphere cast, so instead of casting a single point line, we're casting a sphere. Okay, that's got some volume, that's got some width, it's got a radius. It's going to detect things on either side of that line. Okay, alright, well let's just test that a little bit more. In real time, let's play around with the radius of this sphere. Okay, so if I bring this to the side here, I say, okay, at this point, I'm still detecting, but I don't really want to. Let's bring the radius down. So about 1.7. Okay, I'm not going to change anything with the mouse. I hit E. There we go. You see, it hasn't detected the paper anymore. just bringing that sphere radius down, it's now just detecting the floor, okay? Because the width of that sphere, as it travels down that line, is not intersecting with the side of the paper. We can just prove that. Let's just bring it back up to 0.9. Okay, I'm not moving the camera at all. Hitting the E key, and there we go. You see, raising the width. That sphere. Let me pause it so nothing happens. That sphere is now wider. Okay. Actually, let's leave the line there. I did move the mouse a little bit there. You get the idea. Project B. Okay, so when that sphere is heading up towards 1, it's intersecting on its width there. I bring the width down, and I definitely moved that time, didn't I? Okay, but I think the proof's still there. Okay, so let's see what 0.5. There we go. So kind of like, and that's what I'm saying with play with the values. I expose these values in the inspector. You have to play test. Hit play, check your game out, muck around with these variables that I'm trying to explain to you see how they're working inside and what they're affecting, okay? This sphere radius is just saying, okay, our field of vision, our field of collection vision, okay? Now, I am definitely going to absolutely stop it there because I will start over-explaining it there. And I'll just wait and see what happens in the comments, if that's really cleared a few things up or I need to go further. In the meantime, thanks for watching. See you later.